So today we are going to discuss the way of expressing the concentration of solution. So our topic today is way of expression of the concentrations. Expression of concentrations of solution. So what does it mean? We will find out that what is the way of writing the concentration of a solution. There are different ways, of course. So in order to understand the calculation involving solution, obviously we need to know how to express them in concentration. So let us see. We will start by discussing that mass percentage. First we will start off with mass percentage. Mass percentage. Mass percentage means it is the amount of solute in grams present in 100 gram of the solution. It is the amount of solute present in 100 gram of solution. Remember, we have to solve numericals, so you have to be ready accordingly. So it can be further written as like this, that mass percentage should be is equal to mass of solute in gram, obviously, divided by mass of solution in gram into 100%. Next is mole fraction. Here I would like to give you one example. Is like, suppose A is solute and B is solvent. Okay, and these two will combine to form solution. In that case, what happens is, suppose Ma is the mass of solute and Mb is the mass of solvent. So mass percentage should be written as Ma divided by Ma plus Mb into 100%. Here, this is how we are going to express. So the numericals we have to face, of course, at that point of time, this formula should be utilized. Now, let us shift our attention to the next one, which is mole fraction. So let us see the next one, known as mole fraction. Mole fraction. The fraction, this term will be very, very important. Remember, it is expressed in X. It is the ratio of moles of a particular component to the total number of moles. So let us write down the definition first. It is the ratio of a of number of moles of a particular component to the total number of moles. How will we write? So for that, here also, I will take this case. Suppose components are A and B. There are two components. So Na is number of moles of A, Nb is number of moles of B. So mole fraction of A, which is XA, remember this is mole fraction of A, should be expressed as Na, or I should be writing individual mole by total mole. That means it should be written as Na divided by Na plus Nb. If we can write Na plus Nb is equal to Nt, which is total mole, so it should be Na divided by Nt in case of Xa. This is one thing. Similarly, for Xp, it should be written as Nb divided by Nt. And remember always, if we are doing Xa plus Xp, it should be Na divided by Na plus Nb plus Nb divided by Na plus Nb. So it should be written as Na plus Nb divided by Na plus Nb is equal to 1. And further, we should be able to write that since Xa plus Xp is equal to 1, so in order to calculate the mole fraction of one component, simply you do this. Okay. So this is how we propagate. This is the mole fraction. Now, let us see one case regarding the mole fraction. Let us see one numerical. Suppose a mixture of oxygen and nitrogen are mixed. Okay? Oxygen that is present, suppose 8 gram, sorry, suppose oxygen that is present is say 64 gram, and nitrogen that is present is say 56 gram. Now, if we need to find out the number of moles of oxygen, it should be given mass by molecular mass, that is for oxygen it is 32, so it is 2, and for nitrogen also it is the given mass 56 divided by, for nitrogen the molecular mass is 28, so it should be 2. So we have got the number of moles of oxygen and nitrogen both. Now we are going to apply the formula. We know in case of oxygen, so if we want to write down, in case of N of O2, it should be 2 by 2 plus 2. So it should be 2 by 4, it should be 1 by 2. And in case of N of N2, it should be same thing, 2 divided by 2 by 2. So it should be 2 by 4, which is 1 by 2. And of course, if you add these two, nitrogen, number of moles of nitrogen and number of moles of oxygen, you will be getting half plus half, which is equal to 1. So we have proved that the addition of the mole fraction of two components or three components, whatever it is, it should be actually is equal to 1. Up next, we are going to talk about a very important term called molarity. You must be familiar with this term from class 9 itself. Remember, molarity, as a matter of fact, it is not only important as a parameter for measuring the concentration of a solution. It is such a term which will be utilized again and again from here on in chemistry for solving so many numericals of different type of chapters. So let us see what is molarity. I think you must be already knowing about it. So molarity is defined as the number of moles of the solute present in 1 liter of the solution. So let me write down it first. It is defined as number of moles of solute present in 1 liter of solution. So mathematically, how will we define? Remember, molarity is always expressed in capital M. So how will we define? The definition will be molarity should be number of moles of solute divided by volume of solution in liters. Here, one thing I must say, if it is given in ml, if this one is given in ml, instead of liter, if it is given in ml, in that case, you can multiply it by 1000. Okay. So this is what everything about molarity. And at the same point of time, I would rather like to discuss another term which is known as molality. Very similar, and students often do this mistake of getting confused between the two. So next one is molality. Remember, molality and molarity, only there is this much of difference, and it is expressed in small m. Now what is molality? It is the number of moles of the solute, same thing, present in 1 kg of the solvent. So it is the number of moles of solute present in 1 kg of solvent. Carefully see the basic difference. 1 kg of solvent, and here it was solution and it was in liter. So if we want to define it, molality, it should be number of moles of solute divided by mass of solvent in kg. Here also, I must say one thing. If it is given in gram, then only it will be multiplied by 1000. Carefully see. So both terms are very similar. Only difference between the two is here it is 1 liter of solution, here it is 1 kg of solvent. So depending on the situation, we have to be very careful whether it is given molarity or molality, because molarity means capital M and molality means small m. So accordingly, we have to be very careful. Otherwise, it is very easy to do the mistake over here. Now let us see one or two simple problems regarding this. The question goes like this. A solution is prepared a solution is prepared by adding 2 gram of a substance A to 18 gram of water. Calculate the mass percentage of solute. So I think the answer will be very easy, because here you see mass percentage of A. Suppose A is solute, here it is given already. Mass percentage of A, or you should be writing, it should be written as mass of A divided by, either you write total mass or you can write mass of solution into 100%. So mass of A is how much? Very easy, 2 gram. And mass of the solution, 2 gram is dissolved in 18 gram. So it should be 2 plus 18 into 100%. So it becomes 2 by 20 into 100%. So it is how much? 10%. Very simple case. Next, we are going to calculate molarity. Very simple problem initially I am choosing. Slowly we are going to go for the difficult ones, or I would say comparatively difficult ones. Next one is calculate the molarity of NaOH in the solution prepared by dissolving 4 gram in enough water to form 250 ml of solution. Now, it's a very simple case. First of all, we have to calculate number of moles of NaOH, because we are calculating molarity. So molarity means it is number of moles of solute divided by volume of solution in liters. Further, we can write it is number of moles of NaOH divided by volume of solution in milliliter multiplied by 1000. So here, first of all, number of moles of NaOH. It is the given mass 4 gram by molar mass. How much we are getting? We are getting this value as 0.1. Now, what we are going to do is, when we are calculating molarity, it should be 0.1 divided by 250 ml. As you can see, it is given in 250 ml. This one, it should be multiplied by 1000. Now, as a result, how much we are getting? We are getting 0.04 molar. This is the case. So very simple case of molarity which we have solved. Remember, directly in case of 250 ml, you can convert this one into liter, and then the 1000 you do not have to write. The same thing actually. So today we have faced the problem regarding molarity, mole fraction and all, and we have understood how to express the concentration of different solutions. First you go through it. Next we are going to solve comparatively complicated problems of this particular topics. So meanwhile, I expect you to go through all these numericals and the formulas, so that we can face the problems on the next day.